Sri Saraswati Vidyapeetham providing e-learning classes for 10th class children. Here I am Nagesh from Kamariti, going to discuss about the trigonometry topic. Here the trigonometry word came from the Greek, so which means it is a combination of three words. It's derived as, which means trigonon is a triangle which is having the three sides. Metron means a measure. So it is a triangle measure. So now in this trigonometry, mostly we are going to discuss about the right angle triangle, how the acute angle is changing with respect to corresponding sides, how they are going to change. The relationship between the sides and angles of a right angle triangle is going to be discussed in this chapter. So now let us see a brief history of the trigonometry topic. You can see the person on the screen is a Hipparchus, is a Greek mathematician, established the relationship between the sides and angles of a triangle. Greek trigonometry was further developed by the Hindu mathematicians. They replaced the chords used by the Greeks by half chords, generally we call ardha. So chord means jya. So here the chords used by the Greeks by half chords of the circles with given radii, that is the equivalent of our sine functions. The earliest such tables are in Siddhantas, that is systems of astronomy of the 4th and 5th centuries AD. Like numbers, modern trigonometry migrated from the Hindus to Europe via Arabs. In Aryabhatiyam, we can see here Aryabhata also discussed about the sine functions in the book of Aryabhatiyam in 500 AD. Aryabhatta used the word ardhajya for the half chord, which was shortened to Jya or Jiva in due course. When the Aryabhatiam was translated into Arabic, the word Jiva was retained as it is, and the word Jiva was translated into sinus, which means curve. When the Arabic version was translated into Latin, soon the word sinus, also used as sine, became the common in mathematical text throughout the Europe. The English professor of astronomy Edmund Gunter first used the abbreviated notation of sine. Like this, we can see the Greek mathematicians. Generally, question arises where do we use the trigonometry topic in our real life? That it has emerged in the 3rd century itself, application of astronomy in astronomy, and also you can see it is going to be widely used in the surveying, astronomy and navigation and engineering. In recent time, trigonometry is widely applied in many branches of science and engineering, such as seismology, which reads about the earthquakes, design of electrical circuits, estimating the heights of tides in the ocean, etc. You can see, apart from the astronomy, geography, trigonometry is applicable in various fields like satellite navigation, developing computer music, chemistry, number theory, medical imaging, electronics, electrical engineering, civil engineering, architecture, mechanical engineering, oceanography, seismology, compression, and game development. Here, these all to know a little bit basics about the trigonometry topic. You will study further in intermediate level. Nowadays we are calling as the +1 and +2 level, that is the intermediate level. You will study as the importance of the trigonometry applied very widely. So let us learn the basics of the trigonometry topic. So generally trigonometry it revolves around the right angled triangle. That is, let us know about the right angled triangle. Let me call, here it is a triangle with three sides. Triangle with three sides. One of the angle, one of the angle is 90 degrees. One of the angle is 90 degrees. Then the triangle is called the right angle triangle. The another two angles automatically they become acute angles. Why? Because one angle is 90, then sum of the remaining two angles is equal to how much? It is 90. So therefore, the another two angles you can see in the triangle that is on the screen. Angle A acute angle, angle C is also acute angle. Also you learned that the side which is opposite to the greater angle, which is the greatest angle in this triangle? 90 degrees. The greater angle is 90, the side opposite to it is the longest side. The side opposite to the greater angle is the longest. This longest side is going to given as the name, it is called as the hypotenuse. The two sides which are adjacent to 90 degrees called as the base and altitude. Mutually we can say this is base and this will become altitude. Generally we call legs of the triangle. Legs of the right angled triangle. Namely, AC is the hypotenuse, AB and AC are the base and altitude or respectively. Not compulsory this is altitude. If it is the base, then it is a perpendicular, so therefore it becomes the altitude. Coming to the next part, here a Greek mathematician, namely Pythagoras, has given the relation between the sides of a right angled triangle. So all of you know, let us recall once again the hypotenuse and other two sides. So the principle is given as the square of the hypotenuse, it is equal to the sum of the squares of another two sides. So you can see once again the square of the hypotenuse is equal to sum of the squares of another two sides. Is it clear to you all? Okay, now let us see the relation. Okay, with the name of the sides, the square of the hypotenuse is AC square and the square of another two sides are the AB square plus BC square. So we can call that square of hypotenuse is equal to sum of the squares of another two sides, that is AC square is equal to AB square plus BC square. So these lengths we have to substitute. If it is 3 centimeters, this is a 4 centimeters. 3 square plus 4 square. 3 square plus 4 square. This is 9 plus 16 is 25. This 25 AC square. So that is nothing but 5 square. So you will get this length is equal to 5 centimeters. Like that we used to calculate the lengths of the sides of a right angled triangle. Now we are going to see the relationship between the right angled triangles, that is the relationship between the acute angle and also sides of right angled triangle. So they are given as the ratios in this trigonometry. Mainly you are going to study that I can say like LKG you are studying here basics ABCDs words. So you should be concentrate the base or foundation to trigonometry, these ratios itself. Whatever the six ratios we are going to study, these ratios, with the help of these ratios only, the total trigonometry we are going to discuss. For that, here, once again I'll take here, maybe myself I am disturbing you. Here it is, right angle triangle. You can see I took two right angle triangles. Why? Because when it is a right angle triangle and the two angles I called it as the acute angles. Therefore, I want to, with respect to this angle, that means if I am standing here, therefore this is the theta, means the side opposite to this theta will become, here it is I am giving the y, and adjacent to theta this side I am calling it as the x. and another side is also adjacent to theta, but we are not calling it with another name as the base and altitude. It is given with the name hypotenuse, so therefore you call it as the hypotenuse. Here I am giving the name Z. If I am with respect to this theta in this triangle, if I am standing here, which is the opposite side will become here it is, and which is the adjacent side it is. So hypotenuse as it is. So therefore be careful from with respect to which angle you are observing, with respect to which acute angle you are observing, either this place or that place. Your identification is very much important. There is opposite and adjacent have lot of relation, that is opposite to theta and adjacent to theta, and one another adjacent to theta, automatically we are calling it with hypotenuse. Now the ratio is defined like this. You can see children here, uh, coming to the ratio. That ratio is, if I am going to take the ratio between the side opposite to theta, side opposite to theta by hypotenuse. If I am going to take, for example, here one number is there, this number, this is 3 and this is 5. If I am going to take the ratio 3 by 5, it is given with a ratio that is sine theta. When we are going to find out in further your classes, geometrically by doing the activities, you can learn detailed how, why it is going to call as the ratio. This is the name itself, sine theta. Sine individually it has no meaning. Sine individually it has no meaning. When it is joining with the acute angle theta, when it is joining with the acute angle theta, sine theta is derived as follows. That is the side opposite to theta by hypotenuse. We have to call it always as the sine theta. With the names of the sides, if I write sine theta is equal to y by z, I can write. What is the y? Opposite to theta. What is the z? It is a hypotenuse. So side opposite to theta by hypotenuse, we are going to call it as a sine theta. Do you understand, children? This is the first ratio. This is a basic first ratio, fundamental ratios we call. This first three ratios, you are going to study six ratios. Among these six ratios, first three ratios are called as the fundamental ratios. Sine theta. Okay, before learning why should we call that names, let's go with the next ratio. Here also I'm going to take the same triangles, side opposite to theta and also side adjacent to theta, also hypotenuse. Now I am going to take the relation. One relation is finished, that is opposite by hypotenuse. Now I am going to take side adjacent to theta by hypotenuse. The ratio between side adjacent to theta by hypotenuse is called as a cosine theta. In short form, we call it as a sine theta. What do we call? Cosine theta. In short form, we call it as the cos theta. Sorry, I mentioned sine. It is a cos theta. So the ratio which is defining side adjacent to theta by hypotenuse is called as a cos theta. In terms of length, side opposite adjacent is how much? X, and hypotenuse is how much? Z. So we call it as the x by z with the ratio that is cos theta. Side adjacent to theta by hypotenuse, call it as the cos theta. Going to the third ratio. Here same triangle theta I am taking here, then it will become the opposite and this will become the adjacent. Why? Because this is 90 degrees means its opposite side already giving the name, special name, that is the hypotenuse. Therefore one of these two angles will be the acute and the another will be the acute. If I am standing here, this will be the adjacent and this will be the opposite. Adjacent name is given as the x, opposite name is given as the y. Now first ratio is opposite by hypotenuse finished, sine theta. Second ratio is adjacent to theta by hypotenuse finished, that is a cos theta. Now these two finished and these two finished. Now I am going to take side opposite to theta by side adjacent to theta. The ratio between side opposite to theta by side adjacent to theta is called as the tangent theta. In short form, we call it as the tan theta. mathematically we can write side opposite to theta by side adjacent to theta is equal to tan theta. In terms of lengths, what is the length of side opposite to theta? Y units. What is the length of side adjacent to theta? X units. So therefore, tan theta is equal to y by x. Side opposite to theta by side adjacent to theta, call it as the tan theta. Whereas theta is the acute angle. You can take 1 degree to 89 point something. So therefore, uh, the angle between 0 to 90 degrees is called as the acute angle. So we are going to find the ratios, that the relation between the acute angle and sides. Now I hope the combination of three relations, the all possibilities have finished. You can see opposite by hypotenuse sine, adjacent by hypotenuse is cos, opposite by adjacent is the tan theta. Now if I am going to take them in the reverse as the reciprocal, for example, here opposite by hypotenuse I am going to call hypotenuse by opposite, hypotenuse by adjacent, similarly adjacent by opposite. So now I am going with the next three ratios are the reciprocals of the first three ratios. So first I am going to take reciprocal of tangent only. That is, what is the tangent? Side opposite to theta by side adjacent to theta. Now I am going to take side adjacent to theta by opposite to theta. The ratio between side adjacent to theta by side opposite to theta is called as a cotangent theta. Simply we call it as the cot theta. So mathematically we can write it as the side adjacent to theta by side opposite to theta is called as the cot theta. If we call it as a cotangent theta, shortly we call it as the cot theta. With their lengths, what is adjacent to theta? X units by y units is called as the cot theta. So this is a reciprocal of the tangent. Both are reciprocal to each other. Tan is the reciprocal of cot, cot is the reciprocal of tan. So we can say cot theta is equal to 1 by tan theta also. Have you got it? See, tan theta is opposite by adjacent is there. So if I take the reciprocal, it will become the reverse. That numerator will become denominator, denominator will become the numerator. Now going to the fifth ratio, this is the reciprocal of the cos theta I am going to take. That is the ratio between the hypotenuse by side adjacent to theta. The ratio between hypotenuse by side adjacent to theta, that is z by x, is called with the name secant theta. We call it as the secant theta. In short form, we call it as the sec theta. So mathematically we can write hypotenuse upon side adjacent to theta is called as the sec theta. So with the name of the sides, that is the hypotenuse is z by x, is called as the sec theta. You can see what is the cos theta? Side adjacent to theta by hypotenuse. Now you are going to take reciprocal, it is becoming as the sec theta. So therefore sec theta is also written as a 1 by cos theta. Coming to the last ratio, that is the sixth ratio. First ratio we studied opposite by hypotenuse. Now I am going to tell side opposite hypotenuse by side opposite to theta. The ratio between hypotenuse by side opposite to theta is called as a cosecant theta. In short form, we call it as the cosec theta. What do we call? We call it as a cosec theta. Once again. So mathematically we can write it as a hypotenuse by side opposite to the theta called as the cosecant theta. In short form we call cosec theta. What do we call? Cosec theta. So with the name of the sides, I can say the hypotenuse is z, side opposite to the theta by is y. So z by y is called as cosec theta. Can you say what is this ratio is the reciprocal of which ratio? Oh, reciprocal means we have to make it reverse. That is side opposite by hypotenuse is the first ratio, that is the sine theta. So therefore, if I reciprocal the sine theta, it is going to become as the cosec theta. So we can say cosec theta is equal to 1 by sine theta also. My dear children, now you have studied the 6 ratios. These 6 ratios, we are calling them as trigonometric ratios. So briefly, once again recalling, the first 3 ratios, that is the sine theta, cos theta, tan theta, are called as the fundamental ratios of an acute angle, and the next 3, that is cosec theta, that is the reciprocal of sine theta, sec theta is the reciprocal of cos theta, and another one is the cot theta is the reciprocal of tan theta. So therefore, the next 3, cosec theta, sec theta and cot theta, are the reciprocals of the first 3 ratios. So once again, briefly we can summarize them. 6 trigonometric ratios. You can read very fast that sine A, what is this A? Up to now sir said that theta. Theta is nothing but where it is forming the angle at the place of angle A. So here ABCD is not mentioned here. Angle name is given with red color. This vertex name is the A. This vertex name is the A. Consider this is the B and C. So with respect to this angle, we are going to write the ratios. That means you are standing at this place. You are standing at this place. That is nothing but what is the sine angle A? If angle is not mentioned theta, you call with respect to its vertex only. This is the A vertex. So therefore sine A. What is the ratio? Sine A, opposite. Okay, which is the opposite? This blue color is the opposite. Opposite by hypotenuse. Side opposite to angle by hypotenuse is the sine angle A, which is the cos angle A, side adjacent to angle A by hypotenuse. Adjacent to angle A by hypotenuse. What is the tan angle A? Tan angle A is nothing but opposite by adjacent. It is the opposite by adjacent. Here cosec A. Already I told you cosec is the reciprocal of sine, that is the hypotenuse by opposite is the cosec A. Shortcut we call it as the CSC, but we are writing it COSEC, cosec. As in the previous slide, you can see there, you can write it as the cosec only, COSEC. So cosec is the ratio. You can remember that hypotenuse by opposite. So better if you remember first 3, automatically you will get the next 3, but remember all 6. Now sec A, secant A, that is the hypotenuse by adjacent. If I take 1 by cos A, you will get the sec A. Cot A is a side adjacent to angle A by side opposite to angle A. So whenever you are calling, just don't call sine is equal to opposite by hypotenuse. You must read children. Sine angle A, sine angle A. Then only it has meaning. Sine individually it has no meaning. And angle A is acute. When sine is joining with acute angle, it has the meaning. That meaning is opposite to angle A by hypotenuse. So what we have to take in this place of opposite A? Opposite is nothing but how much length is there, that length you substitute here. How much length of hypotenuse is there, you substitute here. What is angle A? Angle, it may be the 30 degrees, 40 degrees, 50 degrees, 60 degrees. Acute angle I am telling. So therefore, with respect to this angle, this ratio is going to be changed. For example, angle is same. If triangle, the projection is going to be changed. For example, if I extend this length and this hypotenuse, it is going on. If these opposite sides, if I am going at different places, you will get all sine angles for same angle, you will get the same ratios, but numbers may change. For example, if it is coming as a 3 by 5, next may come 6 by 10. Are you observing? 3 by 5, 3 to the 6, 5 to the 10. I am taking, if this length is becoming the 6, automatically this hypotenuse length will become is equal to 10 centimeters. you can do by doing the paper foldings also. Okay, now here it is once again once again by taking an example. Here it is a problem is given how to write. For example, here Pythagoras principle is used, that hypotenuse length is given 5 centimeters and one of the sides, that is the altitude length, is given 3 centimeters. The base length is unknown, that is x value. Okay, here Pythagoras principle we are using leg square plus leg square, that is the altitude square plus base square. Otherwise you can tell a square plus b square is equal to hypotenuse square. Substitute the values, one is the x, another one is the 3. X square plus 3 square is equal to 5 square. So by solving it, x square plus 9 is equal to 5 square is 25. Both sides subtracting minus 9. Both sides subtracting minus 9. It gives x square plus 9 minus 9 cancel x square. 25 minus 9 is 16. Taking the square root on both sides, square and square root cancel. That is, square root is nothing but whole to the power 1 by 2. 2 and 1 by 2 get cancelled. So it gives x. Root 16 value is 4. Now my dear children, you have these 3, 4, 5, 3 sides. Which is the hypotenuse? 5. For example, if I am looking from the C, I am taking the acute angle C. I can find out the how many degrees it has with the help of these numbers. Okay, but we are limited in this 10th standard. We are going to study with limited values of the angles. With the specific angles only we are going to discuss. In higher classes you can discuss for the different angles. 15 degrees you can discuss about the 36 degrees or 75 degrees, like that. But we are going to study for the specified angles in the next classes. Okay, let us see. First let us learn ratio, how to write the ratio. Here the ratio with respect to C. Sine C, what is the sine C? Sine is sine theta is opposite to theta by hypotenuse. Okay, opposite to the angle C is what? 3. By hypotenuse how much? 5. So 3 by 5. Here in short form he wrote that O by H, opposite by hypotenuse, is the sine C. What is the cos C? That is the cosine C is adjacent by hypotenuse, that is the 4 by 5. What is the tangent C? Tan C is the opposite by adjacent, that is the 3 by 4. Coming to the, I'm going in this way, cot, the reciprocal of tan, that is the adjacent by opposite, that is the 4 by 3. That is the secant C is equal to hypotenuse by adjacent is equal to 5 by 4. Sec angle C is the hypotenuse by angle adjacent side, 5 by 4. Cosecant angle C is hypotenuse by opposite. Hypotenuse is 5 by 3. So therefore cosec C is h by O, that is hypotenuse by opposite, 5 by 3. You can observe here 3 by 5 is becoming 5 by 3. 4 by 5 is becoming 5 by 4. 3 by 4 is becoming 4 by 3. All they are becoming changing their places. They are called reciprocal. So reciprocal of sin C is cosec C. Reciprocal of cos C is sec C. And reciprocal of tan C is the cot C. My dear children, uh, now let us use these ratios to learn to by attending some problems. Then we can go to the some of the example problems and some exercise problems. We must get practice. We must get practice of these ratios by attending the problems only, not by hearting the ratios. If you are going on attending 10 or 15 problems, automatically without by hearting, you can remember those ratios. Thank you, my dear children.